Welcome to EDU World Space.
So we can use the ideal gas law in order to solve a lot of problems that have pressure, volume, moles, and temperature. Just a few things to keep in mind. The first is that the value of R, the gas constant, is 0.0821 liters times atmospheres over moles times Kelvin. Now, it's a weird unit, but it means that all of your values in PV equals nRT have to have one of these units. So that means our volume has to be liters, our pressure has to be atmospheres, N has to be moles, your temperature has to be in Kelvin. So you have to make any possible changes to those to make them equal to one of these units before you plug in. So let's take a look at a couple of examples. So say you wanted to solve for temperature. If you wanted to solve for temperature, you have to divide both sides by N and R to get rid of those on that side, right? So if you have the ideal gas law, if you divide by N and R on the right, you have to do the same on the left. The N and the R go away, right? So you're left with T is equal to P times V over N times R. And now we can just take values and plug them in. So if our pressure is 2 atmospheres and our volume is 1 liter, and if we have 0.5 moles, and we have the value of our gas constant, and if you notice, the liters and the liters, atmosphere, atmosphere, mole, mole. So that means we're going to get our answer in the last unit, in Kelvin. And so when we do the math on this, we get 48.7 Kelvin as our answer. We can do this with other combinations as well. So if we, for instance, don't know the number of moles, then we can solve for number of moles by dividing both sides by R and T, right? So then we have N is equal to PV over RT. Now, unfortunately for this problem, the value of T is unknown as well as the value of N, so we're not going to be able to solve part B. In part C, we don't know V, so we can divide both sides by P. We get V is equal to nRT over P. Now we know the number of moles. We know the value of the gas constant. And we know the temperature in Kelvin. Now the pressure, though, is given in torr. If you notice, our unit in our gas law here, constant, is atmospheres. So we're going to have to convert that into atmospheres with dimensional analysis. There's 760 torr in an atmosphere. And so when you do the math on that, do the arithmetic, you wind up getting 11.2 liters to our 3 significant figures. And then finally, if we want to find pressure, we have to divide both sides by volume. And we're going to wind up with pressure is equal to nRT over V. And so we know the number of moles. We know the value of the gas constant. We know the temperature in Kelvin. Oops, sorry about that. Let me just clean that up a little bit here. And then we're going to divide by V. Now we need V in liters, but we're given milliliters. So we have to convert that. 1 liter is 1,000 milliliters. And so we can do the arithmetic on that and get 10.5 atmospheres.